guys, Grafana is flooded with 409 errors. Our checkout is failing, and customers are getting blocked at the last step on Black Friday. Yes, I've been checking it throughout the night. Looks like we are fighting race conditions when two or more customers try to buy the last item at the same time. Wait, but doesn't our system check stock before checkout? How is this even possible? And it's not just a few errors. It's happening across multiple products. Customers get to checkout, but by the time they pay, the stock is already gone. So what's failing, Luca? Inventory or payment? Inventory. The system lets multiple people check out at the same time, but only one of them can actually get the product. Let me show you how it happens. We have one gaming console in inventory. Stock equals 1. Now two customers, Ana and Marko, both see this available at the same time. They both click Buy Now. The cart service checks inventory. The stock is still 1, so both Ana and Marko are allowed to proceed. Now both of them reach checkout and begin payment. But here's the catch. It's not about who clicks first. It's about whose request gets processed first. Ana starts payment. Marko starts payment. When they do, the order service checks inventory again. Stock is still 1, so both payments are allowed to proceed. But this is where things go wrong. Marko's transaction to deduct stock from inventory happens to execute first. When Ana's transaction attempts to deduct stock, the version number for that row has already changed because Marko's order went through first. Optimistic locking catches the conflict, causing her update to fail. The order service detects this and blocks her order before it reaches the payment processing. Since her order never goes through, she gets a 409 conflict error. Item out of stock. Even though she started checkout at the same time as Marko, or even a few moments before. So Ana goes through the whole checkout, thinking she secured the item, only to be told at the very end that it's unavailable. That's frustrating. Exactly. Right now, it's not about who clicks first. It's about which request wins the execution race. And that's why we are getting all these 409 conflict errors. But Nina, at least we are not overselling. The system behaves correctly, though the user experience might not be the best. Still, there has to be a way to stop users from going through checkout just to get blocked at the last step. Bob, maybe you and Luca can work on improving the flow so we don't lose customers due to a frustrating checkout experience. Yes, good point, Nina. Nobody likes going through checkout just to be told, oops, no stock. Luca, let's go over some options and see how we can improve this. Alright, I'll leave this with you too. Let me know as soon as you have a plan to fix it, and I'll make sure it gets prioritized in Jira. Alright, Luca, we can't let customers think they bought something only to yank it away at the last second. Yeah, the problem isn't overselling. It's waiting too long to tell them the item's already gone. We need a way to secure the stock earlier before customers get too far into checkout. Exactly. I was thinking one of the ways to do this is with Redis, distributed locking. Here's how it works. When a user enters checkout, we create a short-lived lock in Redis to reserve the stock for them. That way, no one else sees it as available. So Redis acts like an interceptor. Every request that wants to update inventory first checks Redis to see if the item is locked. Exactly. And not just for updates. If an item is locked in Redis, it won't even show up as available for other users. That way, the first user to enter checkout gets a temporary hold on it, and everyone else sees it as out of stock. Once the payment is confirmed, we update the database and release the lock. Okay, makes sense. That way we don't get multiple people reaching checkout for the same item, only to find out too late that it's unavailable. But wouldn't that mean checking locks on every read operation? That might be overkill. Yeah, checking Redis on every read does add some overhead. We could optimize it though. Instead of hitting Redis for every product lookup, we could cache availability status for short periods. That way, most of the users still get fast responses. And we only check Redis when they actually try to add an item to their cart or enter checkout. Okay, caching availability helps, and Redis locking prevents overselling. Now what happens if someone clicks submit order and then just sits there? Does the stock stay locked forever? Well, the lock would have an expiration timer, but setting it too short means the user might lose the item before they finish entering payment details. And setting it too long means stock stays locked even if they abandon checkout. Neither option is great. Too short and we frustrate real buyers. Too long and stock gets stuck. Feels like we are forcing a trade-off. Are we missing something? Hold on. Are we even checking if the customer is still there? If they've abandoned the checkout page? Why are we still holding stock hostage? How would we even track this reliably? Not everyone moves their mouse constantly. This is turning into a mess. Locking, caching, tracking, what's next? A background process that watches their heartbeat. Wait a second, we are overcomplicating this. Instead of locking in Redis, why don't we just reserve the item in the database? When a user enters checkout, we just mark it as taken without blocking it for everyone else temporarily. Exactly, they get a reservation, not a guarantee. If they check out, it converts to a real order. If not, it expires. No stock locked forever. No manual cleanup. No headache. Alright, that's actually pretty solid. No more fighting locks. No more stale reservations. Just clean, timed holds. I can live with that. And we don't have to monitor heartbeats. Yeah, let's get this packed out. Alright, let's walk through how it will work with Ana and Marko trying to buy the last gaming console. Right now, they both see the GC in stock and add it to their carts. And since our system doesn't reserve anything at this stage, it's still up for grabs. Exactly, whoever checks out first wins. The other gets a nasty surprise when they click pay and Bam! Out of stock error. That's the problem. We are only checking stock at the very last second. Instead, we need to secure the stock earlier. That's where the reservation table comes in. The moment Ana enters the checkout, we insert a row into the reservation table. Exactly, the item is now held for Ana, even though she hasn't paid yet. Here's another problem. Our inventory table only has one column for quantity. That's not enough. So we rename quantity to TotalQuantity and introduce AvailableQuantity. Okay, so reservation holds the temporary stock. But why do we need available quantity? Why not just reduce total quantity when someone reserves an item? Great question. Let's run through it. Ana reserves a GC. If we subtract from total quantity, what happens? Now the stock is 0. Right, but Ana hasn't actually bought it yet. So if she abandons checkout, we already reduced stock permanently. And now we have to undo it? Exactly. And what does Marko see when he checks stock? He sees total quantity equals 0, but that's misleading because Ana hasn't paid yet. Right, now let's do it the right way. Instead of touching total quantity, we reduce only available quantity when Ana reserves the GC. So Ana's stock is held, but Marko still sees the total stock? Exactly. Total quantity equals 1 stays the same because that's our actual stock. Available quantity equals 0 tells us what's really up for grabs. If Ana doesn't finish checkout, her reserved stock is released and available quantity goes back to 1. Alright, but couldn't we just calculate availability dynamically as total quantity minus the sum of reserved quantity? This works. But now, every stock check has to join with the reservation table and run a sum aggregation. That's fine when we have a few users. But what happens on Black Friday? When hundreds of thousands are checking out at the same time. The database gets hammered. Every query slows down. Exactly. But if we store available quantity separately, stock checks become a single lookup. Super fast, even under load. Alright, so Ana's holding 1 GC. What happens when she completes the checkout? We convert the reservation into a real order and deduct from total quantity. And the reservation? Delete it, since it's no longer needed. Now, what if Ana gets distracted and never finishes checkout? The reservation expires, stock becomes available again, and Marko gets another chance? Exactly. Though, if there was still stock left, Marko never had to wait. He could have reserved one earlier. Alright, we are adding a reservation table, renaming quantity to total quantity, introducing available quantity to track available stock separately, and setting up a cleanup job to remove expired reservations. Simple enough, and it makes sense. It's fast, no expensive queries, and no stock locked forever. Did I just hear you two solving Black Friday problems? What's the final decision? We are going with reservation with expiration instead of Redis locking. It prevents race conditions while keeping the user experience smooth. Good choice. No one likes getting their card snatched at the last second. Let's get this into Jira and roll it out. Alright, that's our plan. No race conditions, no last second surprises. Just clean reservations. And that wraps up this video. See you in the next one.